Okay, we're recording. Hi everybody. Welcome to this talk with Daniel Firebanks. Daniel is working with the World Resources Institute on making an open source tool that uses machine learning and NLP to mine policy documents and find policies containing specific incentives. And one motivation for this tool is that a coalition of Latin American countries have made big commitments to ecosystem restoration, and decision makers need to understand the policy incentives supporting them. However, currently this is a really labor-intensive task, and people have to read like thousands of pages of policy documents, by hand, oftentimes outside their areas of expertise. So, like a tool that can automate this is very much welcome. Yeah, I'm personally very excited for this talk, just because this is an overlap of two domains that are rarely seen together, like policy and machine learning. Usually, the coolest stuff happens at the overlap of such domains. So yeah, looking forward. And a couple of logistical notes. I'm Eugene, co-founder of Work on Climate. I will be facilitating this. The event is hosted by the Work on Climate community, as you surely know by now. I'm saying this because oftentimes we have attendees from outside the community too. So for people who don't know, we're a community that helps people switch their careers into climate. Come join us through our website, workonclimate.org. Next, as I said, the event is recorded, and we will be also taking notes. I'm going to paste a link to the notes document to the chat. Yeah, please help take notes. I know that kind of everyone's responsibility is nobody's, but basically, if you're the kind of person who likes taking notes, please assume that your help will be welcome. That is very useful because we have 2,000 plus people in the community, and only like a dozen or maybe two will be attending this event, but we often refer people to past events, and people find it really useful to read through the notes. Okay, with that, on to Daniel.
Thank you, Eugene. I'm gonna, could you enable screen sharing, please?
Oh, of course. One moment. Done.
Perfect. And I just want to confirm that everybody can see my screen.
Yep, I can see it.
Perfect. Okay, so let's begin. Thank you everyone for joining me today. As Eugene said, I'm going to be talking about machine learning for policy analysis, and a particular work that we've been doing to identify incentives for landscape restoration in Latin America using NLP, or natural language processing. And this has been the wonderful work with a collaboration of 3 organizations. So the World Resources Institute, Omdina, and DSSG Solve. And it's been a wonderful collaboration between data scientists and policy experts as well. It was like Kathleen's idea here to kind of create this this type of tool. And okay, so I think that today I was thinking about talking a little bit about the context about why this is needed and why would you use machine learning in the first place. And then we're going to go more into the proposed solution that we have, as well as some results and future work. So this is heavily based on a paper that we have submitted into a public policy conference, as well as a journal that we're still waiting on review and then got accepted in the conference. So I'm going to be basing a lot of this talk on that work. Okay, so some context for the idea. I think that as most of you probably know, this is the UN Decade for Ecosystem Restoration. So just a call for action and collaboration that aims to prevent and reverse the degradation of ecosystems. And as part of that decade, as Eugene mentioned, we have the Initiative 2020. So it's a coalition of Latin American and Caribbean countries that is trying to restore degraded lands and the ecosystem as well. And we can see that it could both have good economic benefits as well as environmental benefits. And so to kind of dive into this project, one may ask, okay, but how are you actually, you have the coalition, but how are you actually going to do that, right? And taking into account one of the techniques that people use are called policy instruments. So that's just a way that a government kind of provides to kind of incentivize people to help them meet their goals, such as restore ecosystems. And these can be in the forms of fines, payments, technical assistance, and so on. So these are just ways of creating incentives for people to restore, let's say, forests. And so, and we'll specifically be focusing on financial incentives here. And so we can get to the question of like why machine learning in policy analysis. And it's a little bit complicated, but essentially I'm going to start by saying what to kind of understand what financial incentives would work best. We kind of need to understand what has been done before and what is currently being done, right? So what policy instruments have been worked or not in the past and which ones are being implemented now. And so as a policy analyst, one might say, okay, I want to find all the policies that contain financial incentives for planting trees in Sonora, Mexico. And so to do that, you may find this website called Ecolex that contains it's like a database for multiple environmental policies from different countries that may or may not be complete or extensive. And when you do that search, you would find, okay, well, you encounter like 12K plus documents to search. And out of those 12K plus documents, you have to kind of go through a lot of them and extract relevant information from those documents. And after that, you want to write like a policy memo or a summary or like a recommendation for decision makers given your analysis. In some countries in Latin America, though, the problem is that this part of the pipeline takes a lot of time and money, and not all the countries have actually access to those resources. And some of them, what they do is they kind of outsource this consulting process to other institutions or organizations, to something called rapid reviews. And in the healthcare policy domain, at least, it has been found that rapid reviews take around like 5 to 12 weeks to create. And this is actually a good thing, because otherwise it would take way longer. But even if countries have actual resources to analyze policy, so people and time, for example, in Chile, they have like an office dedicated to analyzing agrarian policy, but their reports are behind on program implementation by like around 3 years. So you can imagine how it's just not just a problem with the analysis, but then it kind of delays the design of the program and the implementation of the program in a given country. So yeah, main challenge, lack of resources, even with rapid reviews. And so what we thought is that what if in this part of the pipeline, we use the latest machine learning or natural language processing technologies, so that essentially it's an engine that goes through all the sources needed that contain environmental policy, process them, filters them, and essentially you would only need to, let's say, write a query the way you would do in Google. I want to find all the policies that contain financial incentives in Sonora, Mexico. And then you literally get the relevant information, so the relevant documents. And so the only thing you're left to do is, maybe you can just write your memo with all the information that you need without having to read as many documents as you would normally. And we would transform a process that lasts around 5 to 12 weeks into something that lasts around 5 to 12 seconds in terms of the time that it takes to retrieve and find relevant information. And in the future, you could even automate the analysis part, but let's not get ahead of ourselves. This is just for retrieving relevant information from environmental documents. And so that's why we want to add machine learning into policy analysis. And so our goal is, as we said in the title, identify financial incentives for landscape restoration in policy documents, but do so in an automated and systematic manner using natural language processing. And yeah, so is everything clear so far? I don't know if anyone has any questions, you can ask them. Okay, I'm just gonna go into the methodology. Now we're gonna dive deeper into how we're actually gonna achieve this. And so initially, most of the environmental policy is public and available online. And it kind of, you can have websites like Ecolex, which are like a compilation of many different policies, but you can, whatever is the law is generally in a governmental website or an official policy newspaper website, at least in Latin America. And so you can have an engine that basically scrapes the web for those policy documents every once in a while whenever they get updated. And then these documents get kind of processed into different sentences, because policy documents can contain many proposals, and then they generally are in like either bullet points or sentences, right? And this would involve cleaning the text and all these other things. And then we go into a particular process that is, I guess, common in machine learning, which is labeling of the data, because all of these policies are just kind of like raw policy documents that don't have any type of labeling or any type of categorization. So if we're trying to find financial incentives, this is where we would look at each of the sentences or each of the policies and say, okay, this sentence contains a financial incentive in the form of a tax, in the form of technical assistance, in the form of a payment. And that could help us categorize and organize the policies better. And we didn't invent this type of annotation pipeline or labeling pipeline, but we took inspiration from the existing machine learning literature, where essentially you have a database of sentences or policies, and then you have a bunch of queries per each type of category. So for a fine, you have an example sentence or an example policy that contains a fine, or an example policy that contains a tax or a payment. And then we find the most similar sentences to those queries, and then retrieve the top results. And then the policy analysts end up labeling those top results, as opposed to label a bunch of policy sentences. Because you can imagine that for 12K plus documents, for example, you're going to have a lot of sentences, and you don't want people to label all of them, or actually it may not be needed. So we only want to label the relevant sentences, or the sentences that would improve the model the most. And so after that, after doing this process, because as I'm describing the pipeline, I should mention that we have built this pipeline. And we have focused on documents from 5 Latin American countries, El Salvador, Chile, Peru, Mexico, and Guatemala, I think. And we have created 2 data sets. So we want to find whether a policy contains a financial incentive or not. And if it does contain a financial incentive, we want to find what type of financial incentive it contains. And so you can see how we have 6 different types. And these categories, by the way, have been like defined by like policy experts, and also are in confirmation with some UN-based standards. And so there's a lot of literature that is backing this type of categorization up. And we end up with a data set, which all of this was to like a proof of concept. So we don't have like a large data set of like tens of thousands of data points, but we have around like 3,000 data points for incentive, non-incentives, and around like 1,000 data points for which type of incentive instrument we want to classify a policy in. And I guess for those familiar with like machine learning pipelines, we have to train a model to categorize our policies into these different labels. And that means that we have a training set, and that means we have a validation set and a test set. So we train on the training set, the model learns, and then we test its performance on the test set, on data that it hasn't seen before, to make sure that it actually generalizes the knowledge that it has learned. And so after that, we get into the actual classification. Like I said, we want to identify whether a policy contains a financial incentive or not, and if so, what type of instrument does it contain? I guess that an example would be so we take one sentence from like Chilean policies that we have downloaded, and this might get a little bit too technical, so ask any questions if needed. And we use kind of like the state-of-the-art methods for natural language processing, which is called transformers. And we use a particular type of transformer, which is called a sentence transformer, which ends up creating a numerical representation of the text, because the model can't process the text by itself. And then we feed that to a random forest classifier, which is a more traditional type of machine learning method, or statistical method. And that's the one that kind of ends up telling us whether a particular policy is an incentive or not, and which type of instrument. We kind of started with this method, but then we realized we could also just use BERT, again, just the state of the art and kind of out of the box, and it will also yield very good results. And so we kind of we're balancing between these 2 methods. There are reasons behind when we would use one versus the other. If someone wants to dive into that, I can talk about it later. But for now, let's just say these are our two main methods. And finally, we kind of evaluate our performance. So we are using the F1 score because, as you saw in the data set, we have like an imbalance of data points per label. And so just using accuracy would not tell us the whole story, right? Because the model could be classifying everything as incentive or non-incentive. And then that just means that it's just not truly learning to differentiate between what each policy actually contains. But also we have a confusion matrix, which I'm going to show later, about to see how it's performing in each of the categories. And ideally, the output is just like properly classified policies per incentive instrument, and that it's kind of like a component that would be really useful to the policy analyst that is just looking for financial incentives. And I guess a couple of clarifications are that these documents are in Spanish, but the models are multilingual. So you can use it for English, French, Chinese. The only limitation is how good the models already are, because they have been trained on all kinds of data from different languages before. So our only limitations are the bigger languages models as limitations. And so, yeah, that's kind of our general methodology. It's also not something unique, by the way. I think that this methodology is applicable to any type of policy and any type of language. And it's also not new for people that work in machine learning pipelines. We just kind of chose to apply it into this space because we saw that there wasn't really much, at least in our literature review, we didn't see anyone else kind of applying this methodology. Maybe one paper, and maybe some companies, some startups, but the methods are kind of proprietary. And we're trying to open source this to the public. So that's kind of the methodology. And I think that we can jump into the results so you can see that we built this entire pipeline that I just described. And I'm sorry about how small the numbers look like. I kind of wrote them here just to reference. So we achieved like an F1 score of around 88%, and we have like relatively good accuracies for both incentives and non-incentives. And this is using the method of, again, creating numerical representations and then classifying based on those numerical representations. And you can see how the model is able to kind of differentiate, for example, non-incentives versus incentives. This is if you were to represent the policies in a numerical space. You can see that there's a little bit of overlap, that it gets confused, but mostly there are clusters that are clearly defined. And so this is actually promising, even though you might be like, well, this is not 100% or 99%. What do you mean this is promising? And the reason is because these models generally take around orders of magnitude of data and like the thousands or tens of thousands to even be well trained. And so the fact that we're able to achieve this amount of performance with just like 1,000 documents or more than that, or less actually, because the model gets trained in less. It's actually really good, because with more data, then the models will only get better. And of course, quality data. And this is to identify incentives versus non-incentives. And a similar story comes with identify incentive instruments. Again, I apologize about the size of the numbers, but like on average per each instrument, we have around 90% of accuracy, like take more or less. You may see that there are some that is like around 50, and there's a lot of confusion between whatever is a tax deduction versus whatever is a payment. And you can imagine how the model has a little bit of a hard time differentiating between those. But then again, the fact that this color is very light means that we barely had any examples to test. So it kind of says an error in these categories is heavily penalized. So it doesn't mean that it's really bad. And again, when we have an average accuracy of like 90% and an F1 of 0.89, which is, again, given the amount of data, I would say quite promising, especially for a proof of concept. And so that kind of leaves a lot of room for future work. And in particular, you might be wondering, well, how is this actually useful to the analysts, right? So are they just gonna run this model, query a database, and find sentences classified by financial incentives? You would kind of think that you need a little bit more. And the truth is, you do. So first of all, like I said, we have to increase the size of our data set, which we can do now that we know that the model works, like as a proof of concept. We can extend it to other languages, not just Spanish. And we're already doing that with documents from the US, with documents from India. And we're hoping to grow our data set in the next couple of months to have a more improved version of the model. But something very important is are these three things. The first one is named entity recognition. So it's not only useful to know what incentives there are, but it's useful to know which institution is promoting them, who are the targets of those incentives, and is there any conflict between institutions? Like, is there a conflict between the Ministry of Agriculture and the Ministry of the Environment, right? For example, in terms of a policy. And so adding named entity recognition would kind of give us a better information as to how are these financial incentives used. Summarization in terms of like, if you have a document that is like 40 pages long, just a good summary of it, if you know what you're looking for, would be very useful. And specifically also analyzing what topics are treated in the document. So you might find financial incentives that are made for improving water quality, but we're actually focused on landscape restoration. So we got to make sure that the topics also match with the financial incentive that we encounter. But the idea is that eventually what we want to do is create a knowledge graph of all this information that we extract from the documents. And so essentially you would be able to have these documents stored in a knowledge base and then relate them to each other. And so that whenever the user has that initial query that I showed, like I want to find all the financial incentives for planting trees in this area, you're gonna not only know what policies have incentives, but you're also gonna know who is implementing them, what is the target, what programs are associated with that policy, what other policies does this one reference, and all of these things. And so that's how eventually what we want to achieve. And this is actually like, there's one paper on this from 2019 that someone else tried to do something similar for Chinese policy, but we weren't able to find much information of how that effort went. But it's definitely a proof of concept that someone has really wanted to bring into practice as well. And finally, none of this is useful if there's not a usable user interface for the policy analysts to use, because we can't assume that they're going to have programming experience, and they shouldn't need to, so that they can, again, use this the same way that you use Google. I know it's a little bit of a hard stretch in terms of comparison, but it's the same way that you would use Amazon, and you can just filter your search results and stuff like that. And I think that just some final takeaways of this talk is that, yes, natural language processing and machine learning can be used to extract relevant information in an automatic manner. It will save time, and you should use transformers, which are the state of the art in this field. And I want to remind you, and like the reason why this is a big deal is because this framework is extensible to any type of subfield in environmental policy. Again, improving water quality, improving supply chains, improving like chemicals that you use to produce a particular product. And you can do that for any type of language, maybe not a language that is very rare, or rather that is not that there is not much data with respect to that. But it's very extensible. And this is like very key, and this will be very important in the future for more evidence-based policymaking. So yeah, that's all I have, and I don't know if you have any questions. I'll be happy to answer them.
Yeah, thank you so much, Daniel. That's pretty fascinating, especially how well the models work with this limited data. But yeah, let's let people do questions. So Desir has raised his hand to ask a question. Please go ahead, Desir.
Yeah, thank you very much. My question is, trying to go beyond, in future work as well, the potential directions, because you're focusing on policy analysis. But I'm wondering if you also have some view on monitoring and evaluation. I saw that in the data that you had, you were also using newspapers. So I'm wondering if there's a way to monitor, potential newspapers or articles that are linked to, that actually monitor the deforestation or reforestation in those different contexts. You focus on Latam, so I'm assuming we'll be talking about Spanish and Portuguese. But in that sense, I don't know if you have looked into that as well.
So Okay, so two things. These are official policy newspapers, which means that all the policy has to be put in there, right? And we can definitely, the tool, you could definitely write a script that essentially monitors whenever those websites get updated. But if you want to get the actual policy document, you have to get it from the official newspaper. So there is not like there's going to be a new newspaper coming out or a new article coming out in a different newspaper that contains the actual document. Now, if you're talking about the context for these countries, regions, etc., that is an excellent addition that would be ideal to kind of add to the knowledge graph that we want to build. But that's, I guess, a different engine, right? You would have to just write something that purely like scrapes articles from not just newspaper articles, right? You could also social media or etc. But that's not the focus. Like this would be to kind of provide contextual information about the policy as opposed to the policy document itself. So yes, it is doable, but it's not in the scope of this particular project, if that makes sense.
Absolutely, thank you.
Cool, thank you, Desir. Next up, Prudvi, please go ahead.
Hi, thank you. This is very useful and pretty interesting. So I have like two questions. One question is like, what if you miss something in these results? Like, let's say you have 89% accuracy, but there is still a chance to miss some of the documents, probably important, while like people who are analyzing these policies see them and they miss the results and they did not know what they missed. What's the cost of something like this, or how would you avoid this?
No, that's a really, really good question and good point. So right now we're trying to. Okay, so first of all, there's no way of formally verifying whether you have everything, right? How do you know what you don't know in this case? And so what we are doing to try to prevent that as much as possible is really kind of trust and make sure that the way in which the policy analysts find and label data is very systematized and kind of very detailed and informal. So that's why we're not crowdsourcing the labeling. We're making sure that like it's one or two people that know what they're talking about and that they are able to label the data as much as possible. And still, you can imagine how even after labeled data, the model can miss some things, right? Now, the question truly would be, how much would they miss versus how much would the humans miss or policy experts miss? And after achieving, let's say, a better performance than what we have right now, it just comes to trust, right? Like, actually two things. It comes to either trust that, you're comfortable with the fact that you may miss something, but you want to make sure that what you miss is not important. So we can definitely tweak the model and make it more sensitive to policies or texts that we think are most important. And the second thing is that you can imagine in the future, you bring another policy expert and you actually do a formal comparison, right? So you give unseen data to the trained model and to the policy expert and see how both of them perform and kind of just evaluate them, right? And that's how you would compare the performance of the model versus the human baseline, because right now we actually don't have that, but that would be ideal to get in the future. Yeah.
That's very interesting to know. Second question. Okay, while we are discussing, I have another question. Sorry. How long does it take to can you quantify the amount of work that should be done by an expert in labeling the data?
Yeah, we actually were asking the same question to our collaborators, and I mean, this has been 1 to 2 people, and it probably takes them less than a week, like a couple of days of hard work. I would say less than a week, and this was for data in the hundreds, like less than 1,000 data points. Yeah.
Okay.
But if you have more experts, I think it could be probably less. Yeah.
But it's only one-time work, right?
Yeah.
Okay, cool. Okay, my other bigger question is, so now you have shown like 2 different models built, one for financial incentive versus non-financial incentive, right? Other model tries to label it in one of the 5 categories, right? Of what financial incentives are. So when you build this something similar to a search engine interface with a larger context of knowledge graph. So what I'm assuming is you would build models for the kind of queries you expect, and it's going to work in that framework of queries only, right? Like a person cannot come and ask a random question for which the model is not built for, right?
Yes and no. So yes, so we are planning to actually have this in two ways. If we have already trained models for particular categorization, then we kind of already offer that kind of as a way of pre-filtering documents, like the same way that you would check filters in Amazon again. So that's one mechanism. And the other mechanism is more like a general query, like free text query. And we don't, yes, I mean, ideally, if there's something that you haven't trained on, then of course you're not going to necessarily have the best performance. But we're counting on a model being able to, at least the Spirit model is able to come up with good sentence representations of text. And then what we would do is just measure the similarity between the query and whatever is in the document. So if you trust that the representations are good enough for the type of for environmental policy, for the environmental policy world, then you can trust that it's just going to be a matter of, they're already going to be, there will be some policies close to the query, right? That you can just measure by distance. But yeah.
Okay. Got it. Thank you, Dana. This is very interesting.
Yeah.
Cool. Yeah, thank you, Prudvi, for the questions. On to Flora.
Thanks, Daniel, for the amazing presentation. This is super interesting. My question is, so like how many training, like label training data does it take to sort of transfer to, for example, like another language or like another document type, or potentially like, say, if I wanted to sort of is it like transferable to say other questions? For example, I want to find out if there is sort of if a document contains, like, for example, incentives in like some other field, for example, EV, is it transferable?
The short answer is I don't know. But the caveats are that I mean, we are hoping that with the assisted labeling pipeline that we created, you wouldn't need that many labeled examples. So definitely, I don't know, like around like less than 10,000. We're hoping that at most you're gonna have like 10,000 labeled examples, but we haven't tested how a model trained on financial incentives for landscape restoration translates to financial incentives in, I don't know, like to consume a particular type of or just buy a particular type of car, or like energy demand or other things. Hopefully, like in terms of language, that's easier because the models have already been trained on different types of languages, so they're able to already generalize in that sense. But in terms of the field, it's you would definitely need to have some label data, and I'm not sure how much, right? For us, it worked with around 1,000 or less, but maybe more. But again, my guess, and it's just an educated guess, but still a guess, will be that no more than, like, I guess 5,000 to 10,000 documents, but labeled examples, sorry. But yeah, it also depends on your categories and how the nuance among them, right? Like we saw that, for example, for tax deduction and direct payments, it can be a little bit hard to differentiate. So maybe you can focus on labeling a little bit more examples for those cases, but yeah, I don't know. Sorry.
No worries, it's really appreciated, and thanks. And another sort of quick request or question, is there like a public repo that we can sort of play around with the code and potentially contribute to it?
Yes. So the code, so it's not officially open source right now. Like it will be open source once we're done with the prototype. There is a public repo right now that you can either fork or clone and start playing around. It definitely, like, it works for our use cases for now, but it's not necessarily like very written to be very generalizable at this point. We had to be fast in prototyping and presenting results. So, but yeah, there is. I can share the link to the repo.
Daniel, I just posted it to the chat.
Oh, thank you so much. We're not like formally accepting contributions at the moment because we want to finish the prototype before releasing it. But once that's released, then any extensions are kind of welcome. And I mean, I personally also wanted to. This is not with this not as part of this project, but I wanted to kind of build some sort of data infrastructure for this, and so I created a separate repo. So like there's also potential to start contributing there if you want to do it soon. Yeah, and thanks for pasting the link, Eugene.
Mm-hmm. Cool.
Thank you so much.
On to Simona, please.
Hello, thank you so much for sharing. It's super interesting. So I had a question about quality monitoring. I don't know if this is something you guys have dealt with yet, but just how you monitor the model quality and ensure and sort of like determine when you need to do a model retrain. And this is kind of a, for me personally, this is a very interesting question because you know, I built an NLP model, then I started to see that there were new examples coming in that weren't being classified properly. And so I'm currently trying to think through how to build sort of build in an automated system for detecting when to trigger a model retrain. So if you have any insight into that, I'd love to get some.
Yeah, no, that's an excellent question. And I think that the way that we initially designed the pipeline was that as the model gets better, you can, let me actually go back into, oops, wow, that was very fast. Yeah, so after the model gets better here in the classification process, we actually want to kind of redo this annotation pipeline loop where we kind of use the trained model to kind of rerun the query to get the similar sentences and see what needs to be labeled and kind of close the feedback loop. So actually, it's not like we have a detection when, oh, the model should be retrained, but we're constantly retraining it as we get more labeled data and as the model gets better, right? It's kind of like a self-supervised approach. Like at some point we won't need to, there will be a human will be verifying that the labeling is correct. And once that that verification is done, then the data is passed to the model. And hopefully as time passes, the human will need to do less and less verification of the classifications because it would just, the model would just end up labeling more data properly and it will just improve itself better. We haven't built the closed loop yet. It's a desire that we have, and we want to do it after we're finished with some baselines. But that's how we plan to do it. Just retrain the model by augmenting the data, by classifying it, and then feeding that classified data to improve the model itself. If that makes sense.
Yeah, that's awesome. Do you have that code that you've written for that process in the repo for me to look at?
we do not because we haven't closed that. We haven't closed that loop yet. We just have the feeding from the annotation into classification. Yeah. Sorry.
Okay. No, that's. You also mentioned there's a paper about this. Could you share that paper about the human in the loop annotation pipeline, if you have that?
I can share it in a couple of weeks probably when it gets. We're still kind of collaborating with not collaborating, waiting for confirmation from a journal and it's still like under review. And we don't want to make it public yet, even though it got accepted at a conference because I think it's just because of the journal requirements. But as soon as I promise, as soon as it's finished being reviewed, we'll post it, of course, and can send a link and all of that. Yeah.
Okay, great. That's really interesting. Thank you for sharing.
Yeah, Daniel, I have a question too. I think I might be missing something obvious here, but like, what is the query that the user gives to the system? Does the user just ask to retrieve policies that fall into a specific class, or do they like give a free-form text query and you retrieve sentences that are similar to that and then classify them?
So there are two. So if you're talking about the system itself for the final user, the user does like do a free text. It can, the user can use a free text query, like give me all the financial incentives for this region. If we're talking about the labeling process, that has a different type of query. So the query here would be a sample sentence, like a golden sentence for each label, right? So a golden sentence for a policy that contains information about taxes or fines or payments. And that is the query that we use to extract all the similar sentences to it from the policy documents, label them, and then give them to the policy expert to verify that these labels are correct or not. And so this type of query process is not shown to the user. It doesn't have anything to do with the actual user. This is just for our labeling process. So I'm sorry about the confusion. There are those two types of queries.
So I guess I'm asking in the end, like, is the system currently implementing classification or like retrieval?
It can do both. Yeah.
And in that case, I'm wondering, what do you use for retrieval? Like, is it a full scan over the sentences, or do you use something else?
It is a full scan over the sentence. So that's what the BERT is for, and it actually ends up being way more efficient than BERT to kind of do these creation of embeddings and then do the cosine similarity, and you would essentially just compare your initial query, your initial query to all the sentences that exist. I mean, hopefully it will be useful that some of them are already labeled or not, but yeah, ideally that's what it would do. But let me just clarify, we haven't implemented this yet. We have just designed it, and it is whatever is out there is essentially like, you can use BERT by giving it a query, but it's not, you're going to have a user interface, but it's going to give you all the results. You would have to write some code, but that's how we want to implement it as part of the tool. Yeah, does that make sense?
Yeah, that does make sense. I was mainly curious whether it is a full scan or not. Sounds like if you're okay with 5 to 12 seconds, that's probably fine. But there are ways to accelerate it. Like I think Elasticsearch even has some of them built in. Yeah.
So ideally, what we want to do after the knowledge graph is built is you would actually just have. I mean, you would have like a document as an Elasticsearch, like indexed by Elasticsearch, where you would have, for example, like entities, you would have topics, you would have categories, and we would actually just use Elasticsearch to query based on that. For now, we don't have that. That's like something that, again, for future work, but that's kind of like the way that we would use the knowledge graph plus Elasticsearch and stuff like that. Yeah.
Got it. Yeah, I mean, there are ways to speed up the query for nearest neighbors by cosine similarity. But yeah, on to Misha.
Thank you.
Hey, Daniel, thank you very much. This is great. If you can just go back to the slide, or one of the slides that has that classifier 1, classifier 2. Yeah. So in that fine tuning box, tell me about how sensitive the model is, or the workflow is, to this kind of situation where you're kind of doing a binary classification first, and then you're doing a classification on about 5 or 6 label types. Like if we wanted to use this model to train on a multi-label as the first classifier, and then a multi-label on the next classifier, and maybe even add more classifier layers after that, how does that kind of influence like anything that comes before it or after it?
So we haven't, I think we tried, I can't remember if we tried the multi-level classifier and it just didn't end up working as well. So right now we're using 2 models, right? And the reason behind that is because we found that it's better to capture the nuance among distinct incentive instruments by themselves better, as opposed to including the label, incentive instrument types, and then not an incentive instrument or none. And how sensitive would it be to adding more labels? I mean, I think that as long as you're able to just provide good data samples for each of the categories, it should be fine. And I mean, also to come up with a labeling system that is not extremely, very nitty gritty unnecessarily, I guess. Because that may also confuse the model, like not being able to differentiate between 2 things that are debated arguably the same or not. Yeah, but I can't remember off the top of my head what the multi-level performance was, but we can probably give it another try in the next iteration, and I would be able to respond then. Yeah, sorry.
No, thanks. Great stuff.
Yeah, Daniel, can you, I guess, offer some thoughts on where this might develop, like as an ecosystem for policy analysis, or like, yeah.
So, well, I mean, it's a little bit complicated right now because I think WRI is very interested in bringing this tool to use, and given the fact that they have a very wide network, the idea would be that, so they have this program called the Policy Accelerator, where essentially it's like a startup incubator for policy making, and they just bring people from like government officials and other people to kind of think about good policy and focus on that. And I think that this is, for example, one potential use case is offering this tool to the people that are focused on accelerating policy, right? Mm-hmm. I'm not sure about, so we also talked to, sorry, we also talked about to some government officials, and it turns out that they are definitely very interested in the tool. But again, like it's not like we can land a government contract or something like that, right? It's way harder, and there's a lot of bureaucracy involved. So ideally, it would be either for these policy analysts that are in this type of startup accelerator, policy accelerator, or, I mean, you can also imagine how there are other companies or there are other initiatives, like Misha's initiative as well, that kind of want to work with local organizations, for example, and kind of provide better data so that they can take action, right? It's not just for policy making, it can also work for local initiatives. It can also work for, I guess, businesses that are trying to be compliant with some regulations, and making sure that that they're actually not violating some of those regional regulations. So those are kind of the use cases. Those are where I personally see this working, this particular project. But like, I do think there's just a lot of potential if just more people would kind of come together and kind of build an open source tool for where there's this agreement between someone coming in and bringing a new use case, but also developing the code to adapt it to that use case. You can imagine how the tool can just be extended to the sense that you can have both contributors, but also just pure consumers that just literally take on the data as they need. So yeah, that's kind of how I see it right now as it being developed. But I think that we have chosen to not just finish this prototype first, finish like the papers that we're writing and stuff like that, before making it kind of open to accept contributions, right? Because we also need people that manage the repository, and we don't have enough people for that right now, if that makes sense.
Yeah, that does make sense. I think I was basically asking you to, I guess, dream out loud, like what it might turn into, I don't know, like a few years down the line, if other people also got interested in this topic, like what, like where might we go in general with NLP on
Yeah, I mean, honestly, as the models get, my dream is that like I do think there is a lot of opportunity for big businesses that like cloud providers like Amazon, IBM, Google that have these extremely huge models and probably who knows how much proprietary data or proprietary ways of identifying entities, classifying text, etc. And kind of providing this as a service or like targeting environmental regulation or any type of regulation could essentially just revolutionize the entire way of like policy analysis, not just in the environmental side, but like I guess in financial policy or other type of policy that you can imagine. And it's not, I mean, it's not, it shouldn't be rare, I think, like in the next 10 years that you're gonna spend, as governments rotate or as analysts, government people rotate, then they won't have to read the past anymore, and everything will just be documented and everything will just be easily accessible. And it will just accelerate, allocation of funds like way better than the way it's being done right now. And you can even grab insights that you wouldn't have otherwise, because I mean, some people have mentioned, how do you know that this model is not missing important information? Well, how do you know that policy analysts aren't missing some information right now? They have to go through so much text, right? You're very prone to missing something there, which is not to doubt on their absolutely good expertise, but like it just happens, right? Humans make mistakes, and I think that this has but it's hard for us to kind of measure the uncertainty with which we're going to encounter those mistakes with humans, versus you can design a method to guarantee some accuracy or some good performance from a machine, and for it to be constant. So I really like that idea as well, that it is going to be more transparent, more systematic, more automatic, and I would be surprised if we're still doing things the same way that we're doing them right now in 10 years. Yeah.
Yeah, any more questions from other folks? There is not that many of us left, so feel free to just unmute yourself and speak if you have questions. Misha?
I have a question. How did you decide to use a random forest classifier as opposed to some other type of machine learning model?
Well, we started with we started with logistic regression. And then we tried support vector machines and like whatever out of the box simplest models we could find. And it was just the one that had the better performance. And it was also like the one that was able to differentiate the separations among text better. And also doing, for example, a cosine similarity for classifying text, I mean, wasn't ideal and it didn't really work well. So this outperformed that. So yeah, it was a matter of experimentation and also realizing that probably random forests would be more likely to identify separations among categories as well for that particular use case. Yeah.
So did you try any sort of like deep learning neural network?
Well, I mean, the transformer, like the transformer that we ended up using later, that had like a layer, an extra layer of classification, right? That added at the end. So we and it has also like similar performance. It actually, at this point, they had very similar performances given the amount of data that we had. We didn't try like a deep learning neural network from scratch because it didn't seem like it would work well. And with the current out-of-the-box transformers that exist, we already had a very similar good performance.
So you basically are using random forest on the output of a deep neural network, the network being BERT, right?
The network being on the output on sentence embeddings, yeah, on the output of BERT. But also like that's one of the methods, and the other method is just using BERT with a neural network as the final layer, right? So yeah, we're using both.
Cool. Okay. So we're almost at the end. So I guess, thank you, Daniel, so much for this talk.
So thank you for the opportunity.
Yeah, and I also would like to give a special shout out to the anonymous Rhino who has been taking extensive notes in the Google Doc. I don't know who that is, but whoever you are, thank you.
Anonymous Rhino.
The best notes we've had. So just a final reminder, we have a time-honored tradition of sharing one thing you learned after the event. Just go on the Events Vocal channel and share something you learned from the event over there. It's a good way to solidify the knowledge for yourself and also to, I guess, thank the speaker by showing that you remember something from the talk. Yeah, thank you. Daniel, can you please also share the link to the slides with me so I can put it into past events? Yeah, thank you. Okay, thanks everybody.
Thank you.
See you next time.
Thank you so much.
Thank you very much.